All right. Konnichiwa.
こんにちは。
あ日本語がわかりません。英語を話します。ごめんなさい。
No, no problem.
All right. So yeah, let's get started. Um, First, just a quick overview of the agenda. So I'll just do a real quick introduction. I don't know how many of you have met me before. I have been in Japan before. I'll just do a quick introduction. And then I will talk a little bit about what's new in Angular. There's been a lot of developments recently, and so lots of good stuff to talk about. And then, given all this new exciting stuff that's been happening, I'll talk about like what are some of the best practices and ideas that you might want to follow to build like good modern Angular apps. And then we'll have time for questions. So yeah, just a bit about myself. Like Sugar said, I primarily work on the components team doing Angular material and Angular CDK. I've also been doing a little bit of stuff in the Angular compiler lately, so I've got a little bit of experience in lots of different parts of Angular. I have been in Tokyo before. I did the NG Japan back in 2019, so maybe if some of you were there, you remember me from that. I'm sad that like it was all closed down for COVID-19, but I'm super happy to be back and talking to you now. And yeah, so we've had lots of momentum in Angular lately. If you remember in 2019, I was probably talking about Ivy and how we're going to land it soon. Well, that has landed now. That was our big refactor of a lot of the internals of Angular, like runtime and compiler and all that. So that's like done, it's out of the way, and it's helping us to have this new architecture that we can like develop more quickly on, right? And so since we're going to be developing more quickly, we have lots of new features coming out. We've also introduced this new RFC process. RFC stands for Request for Comment. And so basically when we're thinking about making larger changes that might impact developers like you guys, we obviously want to hear what you all think before we just go ahead and do that. And so the RFC process, you can find it in the discussion tab of our GitHub. And basically we'll post new discussions there when we're considering new changes, and we want to hear what you guys think of it. Do you like it? Do you not like it? Are there things you would change about it? So yeah, definitely check that out. And like I said, tons of new features that I'm gonna go over in just a second here. I don't have time to go into detail about everything, but I'll at least give you an overview of a lot of the stuff that's happened recently. So with that, let's learn about what's new in Angular. So going back like a few releases, we're coming up on version 17 now, but like I said, I haven't been here in a while, so I just wanted to kind of recap a few releases back. So version 14, we had a lot of great new stuff. There was standalone components, typed forms, being able to bind to protected members of a class, some cool new CDK components for doing menus and dialogues, and then the inject function to be able to inject things like, you can inject in a property initialization instead of a constructor or something like that using the inject function. Then in version 15, we kind of continued the rapid pace of new features coming out. We had a new API called Directive Composition. We had, in partnership with another team at Google, the Chrome Aurora team, we created an optimized image directive to help load your images more performantly. We did functional router guards, which was kind of a simpler way to do router guards because we know that there was a lot of boilerplate involved in that API. We have better stack traces. So a lot of times, like you see in your stack traces, you'll see all the zone.js frames, right? And so we added some hooks into the new browser APIs that let us strip that out and not have to see all the messy stack traces anymore. We launched new new versions of the Angular material components that are based on MDC. MDC is a library maintained by another team at Google. That team is kind of part of the material design organization, so they, they work directly with the designers who create the design. And so we reworked our components to be based on those in order to give you components that are more true to the actual design. And then we added another new CDK component, the list box. And then in version 16, we had even more new features. Signals, which is new reactivity that we added. We had client-side hydration for the server-side rendering. Vite and ES build support in the Angular CLI. Support for Jest for testing. The ability to mark component inputs as required and just make it an error if someone doesn't provide those. The ability to use data from the router as inputs directly into your components. Self-closing tags, which is a small one, but I think one that people were really excited about. So you don't have to, do the open and close tags. You can just put a slash at the end, not have to type it twice. We added a new take until destroyed operator, which works with RxJS to kind of save you a little bit of time. And we introduced new schematics for the standalone components that we introduced back in version 14 that let you more easily migrate existing code to standalone if that is something that you're interested in using. So I know that was a lot. I want to go over a few of them in more detail. Like I said, obviously we can't go over all of these, but maybe with some of the more important ones we could talk a little bit more about. So standalone components is this new concept that we introduced that allows a component to exist kind of without being part of an ng module. We know that the ng modules, especially for people who are just getting started in Angular, can be a little bit confusing as this extra concept that you got to learn. And so it's nice to not have to use those if you don't need that the power of ng modules, right? And so instead, with these standalone components, we have the components declare their dependencies directly, like what components they're going to use in their templates. And they can either, depend on other standalone components, or of course, if there's an existing chunk of module code somewhere and you want to depend on that module, you can do that as well. And then we can actually take one of these standalone components and bootstrap it directly without putting it in a module. So you can create a whole, Angular app with no ng modules, should you not want to deal with ng modules. Again, we have this schematic I think I mentioned earlier, but that's the actual command to run it that will try to take your existing code and convert as much as possible, convert it to standalone. There may be some edge cases it can't cover, and it might ask you to do something, but it's pretty good. It gets a lot of the cases. And so just to dive in and see what one of these standalone components looks like. So we put the standalone true up here, indicating that this is a standalone component as opposed to a regular old component. And then we have the imports line here, and this is saying the other standalone components and the modules that we're going to use in our template. And so we're bringing in these two. So one of them is this other standalone component. And one of them, maybe I have an old module somewhere that has my card component, so I'll pull that in. And then you can see I'm using both of those down in the templates because I work here. Yeah. And then if, say, I wanted to then take that component and bootstrap it without putting it in an ng module, I can do that using this new bootstrap application API. And normally there's some things that you want to provide at the root of your application, and ng modules gave you a way to do that, but now we're not doing ng modules anymore. And so what we can do instead is, for things like the router, we can call this provide router function, which is now included in Angular. And then if you have, libraries laying around that have those kind of for root style things, you can import the providers from those using this import providers from. So we're able to set up all of our providers and just bootstrap our component directly, just like this. The next feature that I wanted to cover in a little bit more depth is called Directive Composition. So this one actually kind of built a little bit on the previous one. It gives us a new API to compose together directives by attaching other directives to the host elements of a component or directive. And it works with standalone components. The directives that we're attaching must be standalone. So it's a good reason to consider using standalone components and directives. So I think I forgot to mention this on the other slide, but like it's not just components that can be made standalone. You can do standalone directives. You can do standalone pipes. They can all be standalone. And then when we're attaching these directives to the host element, a lot of times they have inputs and outputs. We might not want to expose all of these, right? Like some of them we might consider to be, we're attaching this directive and we're going to configure some of these inputs, but then some of them maybe we want to pass along to the user and let them configure it. Likewise, the outputs. So it gives us the ability to forward and rename the inputs that we choose. By default, the inputs and outputs will not be exposed, but we can choose to forward or rename ones that we're interested in. And then just like a word of caution, don't go crazy with this because it is, adding more directives to the element every time. And so if you overuse it, you're going to wind up creating a lot of directives, and that could cause some memory bloat for your application. So let's just think about where you'll get the most value out of it versus just going crazy and putting high everything. So just to dive in and look at this one, you can see that we're creating a button here. We want our button to have a tooltip when people hover over it, right? And I already have a directive that does this. It's called mat tooltip directive. And so I don't want people to have to like add that to my component manually though, right? I just want them to be able to say, put their button down and say tooltip equals whatever the text could be. And so to do that, I'm using this host directives here. I'm saying that this button is actually going to attach the mat tooltip directive to its own host element. And then it's going to expose the mat tooltip input, which mat tooltip does not, this is my button. I don't want to call it mat tooltip on this. I just want to call it tooltip. So I'm actually going to go and remap that name to tooltip. And now if we take a look at what it looks like to use this, now I can just put my button. I can say that the tooltip is hello, and then it automatically supports the tooltip just like it would if they had manually attached a map. And the last kind of like bigger new feature that I wanted to dive more into is called signals. And so signals is a set of new reactive primitives that we introduced in version 16. There's three of them. They are writable signals, computed signals, and effects. And so when I say reactive primitives, maybe you're thinking like, does that mean RxJS is going away? I thought RxJS was this reactive system wrangler. And the answer is that like, no, it doesn't mean it's going away. It's kind of a simplified version that you can use and that Angular is going to be able to integrate more deeply into our framework. And then if you need the power of RxJS, the power and the complexity and like, the extra size of RxJS, then like you can absolutely still use that. And there's plenty of cases where that makes sense. But, by default, we think it's kind of too powerful for what a lot of users might need. And so we're going to have these signals. And like I said, because we are authoring the signals ourselves, we're going to have the ability to integrate them kind of more deeply into the Angular framework in the future and create even better experience for everybody. And so just to take a quick look at signals, we can see here we're going to create a component to display temperatures. Now you all probably use Celsius and I use Fahrenheit because I'm from America and we don't do anything right. So I want to display the temperature in both, and it doesn't make sense for me to every time update my component and say like set the Celsius temperature, but then also set the Fahrenheit temperature, right? We can figure that out automatically using computation. And so what I'm going to do is use this writable signal, initialize it to 0, I guess, for our Celsius, and then Fahrenheit, I'll just derive from the Celsius one using the formula, and I'll use a computed signal for that. And so that means that every time the value of the Celsius one changes, it will automatically update the Fahrenheit as well. and you can see in the template, I just call these signals to get the value out of them. There's also a .set function if we want to set stuff into them, which we can see here. So now let's say that, maybe I have some service that gives me the temperature and another service to like show notifications to the user. And so when the weather service tells me that there's a new temperature, I'll want to go and update my Celsius signal, and I'll set the new temperature. And now notice I don't have to set anything for the Fahrenheit one. The Fahrenheit one, because it's the computed signal, is just going to figure out, hey, the Celsius temperature changed. I guess I have to change too. So the UI is going to update both of these. And now the effect is basically gives us a way to run some code when a signal changes. Again, since I am American and use Fahrenheit, I don't understand Celsius. I don't know what's hot in Celsius. So I'm just going to write my code using this Fahrenheit one here and check when the Fahrenheit temperature is greater than 100, which is hot in case you don't know. We are going to notify the users that there's extreme heat and they should be careful. And so whenever this fires here, the Celsius setter, that's going to set the Celsius signal. The Fahrenheit signal is then going to automatically update. And then this effect is going to see that the Fahrenheit signal updated, and it's going to run this code. And if our Fahrenheit temperature is greater than 100, it's going to show that notification. So that's a real quick overview of how signals work. So now that we've seen some of these new features, let's talk about how we can take advantage of some of these and what some best practices look like in modern Angular apps. So the first takeaway I'll say is that in a modern Angular app, you want to leverage some of these new APIs to cut back on the amount of code that you have to write. There's a lot of things that we introduced that can help with this: the standalone components, new router APIs, new CDK components, take until destroyed operator, self-closing tags. All these things kind of help you cut back on the amount of code and boilerplate, and that's just a win for everybody, right? It's it's less time for you to create it. There's less code to maintain. It's easier to understand. Everyone's happier when we have less code. And so if we look at an example, I can show how we might use some of these new features to cut back on the amount of code that we're doing. So here we can see setting up some type of library application where I'm going to have books, and I'm going to have routes that has the book / whatever the ISBN number is. And so we can go check out the details about those books. You'll notice that I set up all ng module. I did my router module .for root. I'm doing the lazy loading. Since I want to not load code that I don't need yet, I'm going to go lazy load it, the book component. And then, of course, once I get the module, I got to get the component out of it. And then down here, I can finally bootstrap this thing and start it up. And if we take a look at what the book component looks like, so obviously I'd probably put more details in there, but for a simple example, we're just going to show the ISBN number. And so I'm going to need this observable here to set the ISBN number into. Then in my constructor, I'm going to have to take in the activated root so that in the ng on init, I can figure out, what are the router params for the ISBN, and then I can set that into my stream, and then finally it'll show up here, right? So that's kind of how we did it previously, but we can simplify this a lot now. And so let's take a look at what that looks like. So first, like I said, we have the standalone components now. We don't necessarily have to use any modules, so we can cut that out. And instead of using an ng module and using the router module .for root, I can just do bootstrap application, directly pass it my component that I want to bootstrap, and then I can configure the router in this provide router function instead. And you notice one thing that I kind of changed here. Back up. So it used to be I had to say then take the module and get the component out of the module, right? One of the new things that we added is that if you have a default export from the module, it will use that automatically. And so we don't have to anymore put the .den stuff there. So that kind of shortens that line. And then this line is really cool. This with component input binding. This is the thing I mentioned earlier where we're going to take the router parameters and automatically pass them as inputs to the components. And so why is that good? We'll see when we change the page here. So now my book component looks a whole lot simpler, right? No more of that crazy like activated route stuff. I just have an input. It's called ISBN, and it shows up in my terminal. Yeah, you'll also notice I changed this default comments. That's why I don't have to put the .then stuff. Next slide. And so we can see that this really helps cut down on the amount of code that we have to write, which is great. Sticking with this example of this library application, let's go look at how we might figure out if a book is available for somebody to use. Well, we're gonna maybe get this library service that knows about what books are available in our library. And that's gonna have a little bit on it that's gonna tell us whether the book's checked out or not, so we know, can we give it to someone? Do we actually have it in the building, right? But of course, when we go and subscribe to this library service, we want to make sure that when our component's destroyed, we unsubscribe. So we're going to have this take until destroyed thing. And then that means we got to add the ng on destroyed, and we got to create our stream up here. We have to call next on it. We have to call complete on it, right? So it's just a lot of boilerplate that we have to add in just to be able to subscribe there. But now using this new take until destroyed thing, you can see that I don't need to have the destroyed down there. I don't need to create this like kind of throwaway observable just so I can call complete on it in the end when it's being destroyed. Angular can kind of handle this for me automatically now, and this will make sure that I unsubscribe from my service when the component's destroyed. So I think these examples show how some of these new APIs can really help get rid of a lot of this boilerplate. But it's never going to be perfect. There's always going to be boilerplate that you're going to have to deal with. And I think one of the good tips for like how to deal with this is generate your boilerplate. Don't write it by hand. And so Angular offers some pretty cool tools for this. If you've checked out the ng generate command in the CLI, when you're going to add a new component or directive or module, you don't have to remember all the stuff that's going to go there. You can just like one line type ng generate component, ng generate directive, whatever it is. It's going to add that in with the latest best practices. If you need something like a little bit more complicated, Angular Material also has its own ng generate schematics that can help you add in things like whole address forms and dashboards and navigations that are built using the Angular Material components. And then I'm sure you might have pages that are common in your application that you find yourself writing the same thing over and over again. You can actually write your own schematics just like we do in Angular Material. That's something you can do as well if you find that there's code that you're having to write a lot and you think, hey, why don't I just make my own schematic and generate this? And so that is something that I would recommend to, again, help you not have to spend as much time writing boilerplate code. I think another important thing for modern Angular apps is that we want to focus on the user and really like optimize their experience. And the first bit of that would be knowing like, is my experience good now? How do I know that? And this thing called Core Web Vitals, which is maintained by the Chrome team, is a great way to kind of check that, help you figure out like, is your website loading fast? Does it feel responsive to users? Does it feel like a smooth experience, or is it kind of all choppy? And I'll go into that a little bit more and explain, how you can use that to figure these out. And then, once you know and you think, oh, there's some stuff out there I can maybe improve, Angular offers a number of features that can help you improve some of these metrics. For example, server-side rendering, client hydration, the optimized image directive, and lazy loading. So core web vitals are these metrics that the Chrome team came up with that tell you a little bit about how your user experience feels to users. So there's these three in particular called largest contentful paint, interaction to next paint, and cumulative layout shift. And so largest contentful paint is basically measuring how long from when the user first goes to a website until the biggest chunk of your content loads in. Like how long is that delay? The interaction to next paint is kind of like on average when I as the user come, click a button, type in an input, something. How long does it take for the UI to actually update and me to see that, the thing I did actually had some impact on that, right? And then the cumulative layout shift, this is the one I hate the most when people get it wrong, is the thing where you're going for that button and then like an image comes in and you, you press the wrong button because the image pushed your button out of the way, right? So that's cumulative layout shift. It's when it stuff loads in and kind of the elements on your page are shifting around, and it can be very frustrating to users. So for how to measure these things, Chrome actually has built into the Chrome Dev Console. You might have to go like fish for it, but there's a tab called Lighthouse in there that lets you click like analyze page load. It'll reload your page, and it'll give you some like metrics for these. It'll actually measure, how you're doing on these different scores. And then based on that, what you might want to focus on and what you might want to try to improve. And so, like I said, Angular gives you some good ways to improve some of this. And so looking at server-side rendering, this is a great way to improve your...
This on the west.
Cool. Largest contentful paint. So you can set this up via the Angular CLI by saying ng add universal breath engine. And it's basically, it's going to run your application on the server. It's going to generate an HTML page, and then it's going to ship that HTML page over to the browser. And so, right when it first loads, it'll be there. And then when your code loads in later, it can destroy that and create the interactive version, whatever. This will also help for your SEO because your search engine optimization, because the Google bot or Bing bot or whatever is scanning your website can't run JavaScript. And so if you have server-side rendering and ship over an HTML page, it's going to actually be able to analyze that, improve your search engine score. And of course, it's going to give faster page load than if we just waited for all that JavaScript to load and run it before the user actually sees anything, right? So the server-side rendering is great. It does actually introduce another possible problem, which is you get this page over from the server, and it's just static, HTML. It doesn't do anything. So then when your JavaScript loads in, unless you set up client hydration, it'll actually just destroy all of that DOM and recreate it. And this can lead to like a flicker effect and can impact your cumulative layout shift. And so as a way to improve that, you can use client hydration, which is the new feature that we launched, and it's like an enhancement to server-side rendering. So that instead of just throwing out all that perfectly good server DOM and then recreating it on the client, we can actually reuse it, figure out where do we hook into it to attach listeners, things like that. So then people won't see a flicker, you have better score on your CLS, and it'll be great. And this is just like a one-liner like thing that you import, super easy. So here it is, great. So we just imported this by client iteration. I put that in our providers. We'll have hydration. Another thing that you can do to improve both your layout shift and your load time is to use the optimized image directive that we created with the Aurora team. And so what this basically does is prioritizes your LCP image over all the other images on your page, right? Because like for your metric, you want your largest contentful paint to come quickly, right? We don't want to be spending time loading, images that are off the page at the bottom or something, right? Because you're just not going to see that right away. So it'll prioritize the important ones. It'll also generate source sets for you to load different size images because, maybe depending on the screen that your user's on, you might not need like that super high definition image. And it might be better to load a smaller image that's going to load a lot faster for that screen size. It also comes with loaders that optimize for different CDNs. So, if you're using a well-known like CDN, a lot of times they have APIs that can help you get, smaller, more optimized versions of the image depending on, maybe like the image formats that your browser supports. So that can help. And then it also enforces best practices by just kind of yelling at you if you're doing something bad. Like if you forget to set a width and height on your image, that's going to cause commutative layout shift because the image is going to show up like this initially, and then when it loads, it's like boop, and all your stuff will shift down the page. So you want to make sure that you're setting the height and width, and this will actually throw errors at you if you don't. So that's great. And just quick how to use this. It's actually very simple. It's just an image tag, and instead of source, you ng source, and it just kind of figures things out for you. You say I put my width and height because it would yell at me and not compile if I didn't. And I've marked this image as priority to say like, this is my LCP image, and this is the one that we should optimize for loading quickly. And now lazy loading is another great way to improve these stats, especially the INP, because if we're spending time like loading and parsing JavaScript, that's time that we can't be responding to the user's actions. And so it's best to not load that code until we are actually going to need it. And so examples of things that we might want to lazy load would be like, other routes on our application that the user's not at yet, so we don't need the code for it. If maybe we have a big, table or something and it's all collapsed down so the user can't see it yet, there's no need to load that unless the user expands it. And currently routes act as the lazy loading boundaries. So, if you want to be able to lazy load a component, you like put it on its own route, and we can set it up to lazy load. You can see how that works here. Here we have a side nav that's eagerly loaded on this route. On our about route, we have a lazy loaded component that we, rather than like importing it up here, right, we do the dynamic import to get our lazy loaded component. I know it's not the most convenient to always have to split into different routes, right, for the lazy loading. And so I'll give you a sneak peek of defer blocks, which are something that we're targeting for version 17. But people will probably be mad at me if I commit to that. So probably version 17, maybe 17.1 if that doesn't work. And this is going to give us the ability to lazy load, portions of a template more easily without having to break everything out into separate routes. And it adds a lot of cool features like placeholders, something to show before the content's loaded, like loading indicators while it's coming in, error content if it fails to load for some reason, and we're actually able to customize the triggering logic for when it gets loaded. Because depending on the situation, maybe we want to wait until like a user hovers over some element and then we want to load it, or maybe we just want to wait until the browser's not doing anything else and say like, okay, well, you got free time to load it now. So it'll actually let us configure that. And so this is what, again, like tentative. This isn't final. I know there's been some discussion about exactly the syntax on the RFC. But more or less, this is the API that we're thinking about for the new deferred blocks. So we're going to say like defer on hover, meaning that we want to load this content when the user hovers over. So this is the thing that will get loaded in when they hover. And then we have a placeholder here. So our placeholder is just going to say hover here to load the thing to tell the user they need to hover over. And then once they do that, we're going to get this loading indicator. It'll show like a progress spinner, stuff happening. And once it loads in, we'll see our cool thing. Or if there's some kind of error, we'll get this error block instead. So you can see that this is quite powerful way to do lazy loading. And hope that you guys will enjoy this. And so yeah, looking forward. Deferred blocks, hopefully coming in version 17, maybe 17.1, we'll see. Please join in discussions on future RFCs. Like I said, we really want to hear feedback from the community. We want to know if you guys like these ideas, if you have better ideas. In fact, the deferred loading blocks is a good example. We put out the RFC with that syntax, and we got some feedback from the community saying like that they prefer another syntax, and so we're kind of doing an evaluation right now of which one we think is actually going to be the best. So yeah, we love that kind of feedback, and feel free to follow any of our blog, Twitter, YouTube, all that to find out the latest about Angular. And thank you for coming and listening.